It is important to understand visual representations of fractions and mixed numbers. We briefly introduced this in a previous video. Let's determine the fraction that represents the shaded region for each picture. Up first, we have this circle. Remember that the numerator is the part that we're focusing on. In this case, we have 4 shaded regions, so the numerator here is 4. The denominator is the total parts in the whole. So if we count up the parts, we have 1, 2, 3, 4, 5, 6, 7 total parts. That's the denominator. So this circle represents 4/7. In part B, we have what will become a mixed number because we have a whole circle and then part of a circle. So this first one is a whole circle. We can think of that as 1. And the second part is part of a circle. We have 3 shaded regions, so the numerator is 3, and the denominator is the total number of parts. It looks like there are 5 total parts in that circle, so we have 3/5. The mixed number, 1 and 3/5. We have 1 whole and then 3/5 of the second circle. Let's plot each group of fractions on a number line. Up first, we have -2/3. First of all, since it's negative, we're going to be to the left of 0, and we want to break up the number line a little bit into thirds. So we can use extra tick marks here to represent that. We'll add 2 tick marks since we're breaking that region into thirds, indicated by the denominator. And we want to focus on -2/3. So we have -1/3, -2/3. We'll shade in this point. This point represents -2/3. Up next, we have 1/3. This time that's positive, so we'll be to the right of the 0. We need to add in some tick marks. Again, we'll break that up into thirds. So we have 0, 1/3. We'll go to this first tick mark, and that represents 1/3. Now, 4/3. We have 1/3, 2/3, 3/3. We need to come over here to 4/3. So again, we'll break this region up into thirds, and this represents 4/3. Again, starting at 0, we have 1/3, 2/3, 3/3, 4/3. In example B, we have 4ths and a half. So we're going to be breaking the number line up into fourths. Up first, -1/4. We need to be to the left of the 0. Let's first break up that region into fourths. Notice that going from 0 to -1, we have 1, 2, 3, 4 regions. And we're looking for -1/4. That will be the first tick mark to the left of the 0. Up next, we have -5/4. So we have -1/4, -2/4, 3/4, 4/4, 5/4. So we need to be over here. Let's add some tick marks to help us with that. Again, we'll break that region up into fourths. And we're looking at this point, which represents -5/4. Again, starting at 0, we have -1/4, -2/4, -3/4, -4/4, -5/4. Now we want halves. We have 5 halves. This time it's positive, so we'll be on the right side. We can break that side up into halves. So we'll just add 1 tick mark there between each integer. We're looking for 5 halves. So we have 1 half, 2 halves, 3 halves, 4 halves, 5 halves. This tick mark represents 5 halves. And in example 6, part A, Of the 14,146 McDonald's restaurants in the United States, 1,233 are in California. What fraction of the McDonald's restaurants in the United States are in California? So we want to write a fraction here. The numerator is what we're focusing on, 1,233. And the denominator is the parts in the whole. In this case, there are 14,146. And part B, of the 50 states in the US, 31 have national parks. What fraction of states do not have national parks? So be careful there. This question can be a little misleading if you're not careful. We know that there are 50 states total, so that will be the denominator, the parts in the whole, and we want to know how many do not have national parks. We're not going to put a 31 here. It tells us 31 do have national parks. So to find the numerator, the number that do not have national parks, we have to do a little bit of work on the side. We have 50 total, 31 of them have national parks. So let's subtract to figure out how many do not have national parks. We get 19. 19 do not have national parks. So what fraction does not have national parks? 19 over 50.